Okay, solve the equation. Now, when we're solving equations, especially in this, we need to look at what degrees our variable is to. It's to the second power, okay? But that's the only power it's ever to. I mean, there's no other degree of x, so it's x second only. So if it's an only, we are definitely going to apply the linear properties, okay? So, we're going to put how many answers? There's got to be two, okay? Collect the x terms if you have more than one. We just have one, and we solve it. So this is what solve means. You got times 3, a second power, and a minus 60. So you got to take out your minus 60 with plus 60. You got to take out your times 3 with divide by 3, and then you take out your second power with a square root. So I will be adding 60 to both sides, and that's 147. Then we will be dividing by 3, and then x to the second power equals 49. That's what that. And then I find the square root of 49. That finds a number times itself. That's 49. 49 is a perfect square, so it's 7. Okay, so it could be 7 or negative 7, because any time a square root could be the positive or the negative root. Okay, now number 2, we have 4x to the second power plus 16x equals 0. So I have x to the second, and I've got x to the first. So that's same variable with two different degrees. That is when we have to apply our factoring properties, and then trying to use the zero product property. So there's two answers. So in factoring properties, we already put how many answers that equals 0, so you check that. Count the number of terms. There are 2, so it's a binomial that I'm factoring. So it's GCF, then seeing if I have a difference of perfect squares. So I do have an x on the end. I don't have the negative. Then 4 and 16 is 4. So we will factor out the expression 4x. That is an x, so that definitely is worthwhile. So 4 divided by 4 is 1. X second divided by x. That's just a cancellation. We have a remainder x. 16 divided by 4 is 4. Then x divided by itself cancels. Now, we're checking this. Well, they're both positive, so it can't be a dots if it's a difference of perfect squares if they're the same sign with two positives. So you write no, and you put the 1x plus 4 right alongside the 4x. So 4x times 1x plus 4. So F1, F2. Now I use the zero product property where I set each of the inside of my factors equal to 0. Okay, so divide by 4, and x would equal 0. Then take out the times 1, don't need it. So you subtract 4, and that's negative 4. Okay, so 0 and negative 4. Number 3, we have x to the second power minus 12x plus 27 equals 0. So we have x to the second and x, so we have to apply factoring properties. So we have two answers for x. 0's there, so check it. So now you have 3 terms to factor. It's a trinomial, so we want to look at the GCF, then use our t-table to find the factors that add to the middle. Okay, so GCF. And the t-table. Okay, so no x on the end, no negative in front. 1, 12, and 27 is 1, so we're not going to do that. So ABC. So 1 times 27 is 27. It's positive, so then the signs of the factors have to match. So we're adding to negative 12, so I think they'll stay as negatives. So 27 divided by 1 is 27. That adds to negative 28. That doesn't work. 27 divided by 2 is a decimal. 27 divided by 3 is 9. So put 3 with 9, and I add those, and that's negative 12. So you put in your negative 3, negative 9. Now the a is 1x to the second, so it's x times x with a 1 coefficient on each x. Now really, 1 and 3 really is only divisible by 1, and that's the same with 1 and 9. So that will stay 1x minus 3, and that will stay 1x minus 9. So F1, F2. So 1x minus 3 could equal 0, or 1x minus 9 could equal 0. Multiplier 1, get rid of it. Add 3 to both sides, and x equals 3. Get rid of the 1, add 9 to both sides, and 0 plus 9 is 9. 3 and 9 are the two roots. Okay, now on number 4 we have 12x to the second power minus 11x plus 2 equals 0. So I have x second, and I have x again, just like I did up here, so we have to apply the factoring properties. So you have two answers. The 0 is there, so we are factoring a trinomial. So same as the last problem, GCF and table. So no x, no negative, 12, 11, and 2. That's just going to be 1, okay? A, B, C. So the AC product, 12 times 2 is 24, and it's positive, so that's a match, okay? Okay, so negative, negative, and we have to add the factors to try to get to negative 11. So 24 divided by 1 is 24. That adds to negative 25, so that's a no-go. 24 divided by 2 is 12. That adds to negative 14, so that can't be done. 12 divided by 3 is 8, and there's your negative 11. So your a is 12x to the second, so you put in your negative 3, your negative 8. So xx, and then I apply the 12 coefficient to each front. Now it's not going to stay 12 because we have to simplify. So 12 and 3 are both in the third row, and then 12 and 8 are both in the fourth row. So these are divisible by 3 and 4 respectively. So that's 4x minus 1, and this is 3x minus 2. Now is 4 times 3 12? Yes, it is. Is negative 1 times negative 2 positive 2? It is, so I did that right. So you have 4x minus 1 and 3x minus 2 equals 0. So F1, F2. So 4x minus 1 could equal 0, 3x minus 2 could equal 0. So I add 1 to both sides, that gives me 1. 4 times x equals 1. 1 divided by 4 is 0.25, or you can just put 1/4, I don't care. 0.25 is okay to put. Now over here, plus 2, 3 times x equals 2, but when you divide 2 by 3, you get a never-ending decimal, so you want to keep that as 2/3, okay? Okay, number 5, negative 4x minus 3 equals 17. Now this one we have x without a power, and that means it's to the first power. Don't put a first power. X only. So again, that is linear properties. So this would be only one answer, and I make sure there's only one single x, and there is. Now I solve. It's got times and minus, no power. So we plus the 3. We divide by the negative 4, but we're not doing the root because there's no power on the x. So I would add 3, and that's 20. Then I would divide by negative 4, and 20 divided by negative 4 is negative 5. There's your answer. Okay, number 6, 5x to the second power plus 1x minus 9 equals 0. So in this one we have x to the second and x again, so we have to use factoring properties to find the correct number of answers. Okay, so x to the second, there would be 2. The zero's there, you can check it, and you have a trinomial. So GCF and the table. So no x, no negative. 5, 1, and 9 is just 1. Okay. So 5 times negative 9, that's going to be negative 45. So I'm finding two factors of negative 45, so that's a mismatch. It's got to add to positive 1. So 45 divided by 1 is 45. That adds to negative 44. That's too wide. Okay. 45 divided by 2 is a decimal. 45 divided by 3 is 5, 15. Now I add those, that's negative 12. You're still too wide, so you keep dividing. Decimal, 5 and 9. A 5 plus a negative 9 is negative 4. You're too wide still, not by much, but you're still too wide. Then divide by 6, decimal. Divide by 7, decimal. Divide by 8, decimal. And then you divide by 9, you get 5, but I've already put 5 and 9 down. So that's all the factors, and it's a quadratic formula then. So x equals opposite of b. So again, if the sum is too narrow or you start up here greater than 100, then you can use a quadratic formula. No other reason. Or if you repeat the same factor. So opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a over 2a. So opposite of positive 1 is negative 1. And then b to the second, b is 1. A is 5, c is negative 9, and then a on the bottom is 5. Okay, so you got a negative 1, and then on bottom a 2 times 5 is 10. Now we got to figure out what the square root is, the discriminant. So we know we got a 1 to the second inside there, and we have to subtract the product of 4, 5, and negative 9, and that's going to be 181. So that's a positive negative, so I find the square root of 181, and that's going to be 13.45. So we'll be taking negative 1 plus 13.45, clicking equals, and then dividing by 10, so that's 1.25. And then we'll be taking negative 1 and subtracting 13.45, clicking equals, then dividing by 10, and that's negative 1.45. So both of those are approximate solutions to the equation. Okay, number 7. X to the third power plus 9x to the second power minus 4x minus 36 equals 0. Okay. So I've got x to the third, x second, and x, 3 different degrees. So obviously factoring properties is the what to use. So there's three solutions. Zero's there, but you have 4 terms now. That's a quadnomial, so you need to factor by grouping and then difference of perfect squares. So grouping plus parentheses, and the GCF lines out of each parentheses. These are going to become 2 binomials that we'll factor the GCF out of. Then a little parentheses, big parentheses, and we're going to need to see if that's a difference of perfect squares right there in the end. Okay, so I have 1x third plus 9x second. And then I have the negative 4x minus the 36. Now, these both have a common, both the 2 terms have an x, but we want to take the second power one. So no negative 1 and 9's 1. x, no, be negative. Then 4 and 9, or 4 and 36, excuse me. 4 and 36 would be 4. So I'm dividing by 1x second here, and I'm dividing by negative 4 here. So that's 1, x third divided by x to the second would be a remainder of x, and then 9, and then the x second divided by the x second is a complete wipeout of x's. Then over here, that's 1x, and negative divided by negative is positive, and 36 divided by 4 is 9. So we have the equivalent expression of 1x plus 9. I factor that out. Then I put my 1x second with my negative 4. Okay, you can take the 1's off. So the x plus 9 just comes over here. Okay. This is where you might have a difference of perfect squares. You got a positive and a negative, and x second's a perfect square because that's x times x, and then 4 is a perfect square because that would be 2 times 2. So x, 2, 2. So replace that with x plus 2, x minus 2 equals 0. So now I got f1, f2, f3. So x plus 9 could equal 0, x plus 2 could equal 0, or x minus 2 could equal 0. So I'll be subtracting 9 here and getting negative 9. I will be subtracting 2 here and getting negative 2. I will be adding 2 here to get positive 2. So those are your 3 answers. Okay, now number 8, we have x in a parentheses, so we got x minus 3. Now the question is, do we have a power to that parentheses? We don't, okay? So I want to solve this by distributing. There'd be only one answer for x, so you just apply the distributive property like old times. So it's 4x plus negative 12 equals 16. 4 times 1x, 4 times negative 3. Now you use linear properties, you plus the 12, and you divide by the 4. No power, because there's no power, so plus 12. And that's going to be 28. 4 times x equals 28, and then we divide by 4, and x equals 7. Okay. Now on number 9, we have the x inside of a quantity with minus 4, and it's to the second power. So we cannot distribute. The second power blocks you from being able to distribute. So you want to replace this with an h variable. Now x will have 2 answers, and we have to find them both. But know that you cannot distribute because the parentheses is squared. So you are blocked. So you replace that quantity with h. So 3 times h to the second power equals 18. Now remember, your job is to find 2 answers for x. Okay? So we're going to set up a table where we bring back the x minus 4, and it needs to be on 2 sides. And the reason it does is because I need to divide first, divide by 3, and then I'm going to have to apply a square root to take care of the second power, and those always end up as positive and negative. So we would divide by 3, and that's 6. So I find the square root of 6, so it could be positive or negative. And then the square root of 6 is 2.45. So I could go 2.45 or negative 2.45. So plus 4, and you get 6.45. And over here you plus 4. And negative 2.45 plus 4 is 1.55. Okay, story prompts. A picture is 20 by 25 inches. A person will build a frame around the picture. After the frame is built, it takes up a space of 644 square inches. How wide is the frame? Now you're talking about a shape here, so you make a rectangle that's 20 by 25. That's not drawn to scale. Okay. Then we're putting a frame on the outside. Now you remeasure the dimensions. Okay. This is 20. Now the outsides are that's the answer to the problem. So that x and x. Then the width, you got 25 in the middle, then x is on the outside. So it's 2x plus 20, 2x plus 25. So I need to write the equation for my area. So length times width equals area. And the area we have is 644, but the length and the width, we have 2x and a 20. So 2x plus 20, and then 2x plus 25. So we have to execute the FOIL method, okay, before we can move on. So we take 2x times 2x, then 2x times 25. It's done. Now 20 times 2x, and 20 times 25. So it's going to be 4 with x second. It's going to be 50 with x, 40 with x, and then 500. X second, x constant. Simplify your products. You'd have a 4. 50 plus 40 is 90, and then 500. So bring that over here. 4x to the second plus 90x plus 500 equals 644. Okay, so now I can solve. I mean, the x is to the second and it's to the first, so we have to apply the factoring properties. So there's two answers. This needs to be a 0, so we subtract the 644, and I find that 644 can go with 500. So we have x to the second, x constant equals 0. So we have 490, and then 500 minus 644, okay. You can either go 500 minus 644, or you can add the negative. It's negative 144. Okay, so that's 3 terms. It's a trinomial, so it would be GCF and the t table. So I don't have x, don't have the negative. 490 and 144. Well, it can't be 4 because that's 90. Now 2, okay. Notice how it runs out of room. So take all these numbers and see if you can divide them by 2 without getting a decimal. You get any 3 of them get no decimal, and no decimal there either. So 2 is the GCF. You can divide all of them by 2 without getting a decimal. Okay, so I factor the 2 over here, and I divide all these by 2. So that's 2x to the second, positive 45x, and then this is going to be negative 72. So you get rid of that. Now this is your new trinomial. So 2 times negative 72, that's going to be negative 144. That's over 100, so I'm just going to go to the quadratic formula. So opposite of b, plus or minus d square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of positive 45 is negative 45. Then b is 45. And then a is 2. And c is negative 72. Now down here we have a, so it's 2. Get rid of that. That's not needed anymore. So you have negative 45. On bottom, 2 times 2 is 4. Then we need to find what the square root is. So I enter this in, 45 to the second minus 4, 2, negative 72. So I got 2,601. Now I find the square root of that. It could be positive or negative. So the square root's 51. So we will be taking negative 45 plus 51, dividing by 4, and we get 1.5, 1.5 inches. Then negative 45 minus 51, divided by 4, is negative 24. So negative 1.5 is the legitimate answer. So that means the border is 1.5 inches long. Okay, so 20, 1.5, 20, 1.5, 1.5, 25, 1.5. Okay, an object is thrown upward from a starting height of 15 feet with an initial velocity of 35 feet per second. How long will it take the object to hit 0 feet? So we're finding the number of seconds. So seconds, and that's feet is a function of seconds, so x is your time and feet is y. So feet per second. Quite clearly states that that's 35, but then it goes up 35 feet per second initially, but then it's going to come back down. Okay, it's pulled up and down by the force of gravity, so negative 16 x to the second power. Up, down. So it starts at 15 feet, and then it closes at 0 feet. And of course I put a question mark with the 0 feet, and I'm trying to find the number of seconds it takes to get to 0 feet. Okay, so we line up our equation, so x to the second plus x plus constant equals y. So negative 16, 35, and then 15. So 0 feet. Feet is equal to y, so we put 0 in for y. And then I have to solve for x. Now what do we know about x? Well, it's to the second and to the first, so it's the same variable at different degrees. So we have to apply our factoring properties to solve this. So there's two answers. 0's there, so you have 3 terms. So it'd be GCF and the t-table. So x on the end, nope. Negative in front, yes. 16, 35, and 15. So you look at 15's row, but you can't use 15. Here's 15, nope, no 16. Nope, 15, 35, but no 16. Okay, here's 15, nope. So I guess it's just going to be 1. Okay, so 1. Then you divide by negative 1, and that's going to be 16x to the second, negative 35x, negative 15. So ABC. Now 16 times negative 15, the AC product here is going to wind up being over 100. So if it's over 100, I'm not going to make you waste time trying to find the factors. Just put QF and we just won't factor it. So get rid of that. So, opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So opposite of negative 35 is positive 35, and then B to the second, so you're going to have negative 35 to the second, minus 4, A is 16, C is negative 15, and then A on the bottom is 16. Okay, so we have 35, 2 times those 16 is 32, then I figure the inside. So I've got negative 35 to the second power minus 4, 16, negative 15, 2,185. Now I find that square root. So the square root of 2185 is going to be 46.74. And that is a value we will be adding and subtracting. So 35 plus 46.74 equals, then divide by 32, and you get 2.55. We take 35 and subtract 46.74. And then divide that by 32, negative 0.37. So the 2.55 seconds is how many seconds it took to get to 0 feet. It was never at 0 on the way up, because it started at 15, hence the negative solution. Okay, then the last one in this vlog. A football is kicked off the ground at a velocity of 56 feet per second. After how many seconds does it land on the ground? So we have feet and seconds. Seconds x, feet is y. So feet per second. 56 times x, so it goes up, comes down, pulled by the force of gravity, so we know it's a quadratic function. We're finding the seconds. Okay, so there's nothing before 56 feet per second, so it would have started at 0 feet, and then the ground is 0 feet after it. And we have to find question mark seconds. X to the second, then x, then the constant equals y. So you got negative 16, and then 56. 0 occupies the constant, so we really don't have a constant if there's a 0. And then the 0 feet goes into the equation for y. So y is replaced with 0. Okay, so in the solution box we're solving for x. We have x to the second and we have x. We are applying our factoring properties. So there's two answers. And we have our 0, so there's the two terms, so it's a binomial, so it'd be GCF, difference of perfect squares. So x on the end, yep. Negative in front, yep. 16 and 56, not 16. It'd be 8, okay? So negative 8x will be factored out. So then I go up and divide by negative 8x, and we have 2x second divided by, oops, we got to set up the dots box just in case. Okay, so continue to divide. You have 2, and then x second divided by x is a remainder of x, and then 56 divided by negative 8 is negative 7. And the x there is just wipe out. Okay, now we see if this is a difference. We have a positive and a negative, so it's a difference, but the problem is 2 right away is not a perfect square. 1, 4, 9, 16, 25, those are your perfect squares. So you write no, and you put 2x minus 7 next to it. So F1, F2. So negative 8x could equal 0, or 2x minus 7 could equal 0. So you divide by negative 8 and you get 0. Then you have times 2 minus 7. So you would add the 7 to get 7. Then divide by the 2. 7 divided by 2 is 3.5. Okay. So the higher answer is 3.5. So it would be 0 feet. It would take 3.5 seconds.